Hey folks, let's do a quick review of some Comet ISON facts. We'll start at the JPL orbital diagram for C-2012 S1 ISON. It is currently inside 1 AU, Earth's distance from the Sun, at the white circle, tilting to show the trajectory of the comet from the orbital plane of Earth. You can see this comet has a significant incline up and out of the system after its fairly flat arrival. Now the first worry with Comet ISON was about meteors. Because of how shallow the incoming trajectory of the comet comes in, any breakup before it got to Earth's position could have left large chunks in our path, but it just didn't happen, and a dusting light show is probably the most we will see. But well before that, we will watch Comet ISON plunge towards the Sun. Here is the main concern at this time. Despite the fervent denials of any connection between comets and solar flaring by NASA and other experts, tens of thousands watching here every day, and many more across the world watch sun-diving comet-induced major flaring one after another. We'll discuss this more in a few minutes. We may or may not get a great show from the comet on its way out. That's the least predictable aspect of the comet. But we do know it will likely fly high out and away as Earth moves in to where the comet crossed our path months earlier. We will arrive there in mid-January, and again, probably shouldn't expect more than an aesthetic light show. At the end of this video, the JPL diagrams will repeat but zoomed out so you can see how I'm using the program, and then follow the link given in the About tab to explore this for yourself. If you have Stellarium, a free program from stellarium.org, and you want to import ISON there to track its movement, scroll to the left side and pull the panel that has the configuration window, or hotkey F2. Go to Plugins up at the top, then Solar System Editor. Then click Configure, switch to the Solar System, and click the Import button at the bottom of the box. Select Comets up top, then select MPC List of Observable Comets in the center. Then Get Orbital Elements at the bottom. You can pick and choose, but I hit Mark All and then add the objects. Now if you want to find something you have imported, pull up the search function, also from that left side. You have to type in the full name of the object. Just ISON or Comet ISON is not going to work. You can also use the date and time function, also on the left, to go forward or back to know where things will be. This program has so much more functionality than I've shown here. The comet will be closest to Earth on December 26th, although it will be nowhere near us really, flying up and away to the north. We'll arrive at ISON's debris stream January 15th. We have many known annual meteor showers between now and then, so don't be mistaken. No meteors you see before mid-January have anything to do with ISON. Now what follows is this week's fly-on-the-wall ISON discussion. I thought it complemented this video, so this week's bit is public. We add about an hour of new discussion to the website on the most relevant topics every week. It is just audio, but it helps to pull up another tab or window and track along with us as we often direct you to certain websites so you can see what we're talking about right along with us, but at your own speed. Comet ISON. We are into the second week of November, and the comet has officially started to brighten. You pull up Bruce Gary's site and saying the inner coma continues to brighten at the recently established rate of approximately 15% per day, and that there might be a coma on the sun-facing side. This is very interesting, and this goes back to what we've called the main secret of ISON, the big deal, why it waited so long to brighten, why it stayed so calm and so dark for so long. And the idea about there being a sun-facing jet or some kind of coma structure has to do with the fact that it's got what I kind of playfully called a monopolar trajectory. That is, that the comet is spinning in such a way that you could point to the two poles around which it spins, its axis if you will, and one of those poles, the axis is pointing right at the sun, pretty much right on its directional plane, or directional trajectory. And so a good bit of the comet has been dark this whole time, hasn't been hit with solar wind, hasn't seen sunlight, nothing. And so there's a whole lot of potential built up there, um, that we potentially haven't seen yet. And we really are now awaiting the next significant time, which is perihelion. And with me here I have Xavier, Mr. Too Tough, Billy, and Star Observer, or Telluric Current, now on YouTube. And you guys all know what we're waiting for at perihelion, the chance that this thing is going to induce large flares, right?
Yeah.
This is the electric comet, the electric comet idea, a la Thunderbolts, a la the electric universe. I don't know, what do you guys expect? I'm curious. I'm going to give my opinion in a second, but what do you guys think is going to happen, given all that we know now? I mean, we were worried when it didn't brighten, that maybe this comet was a complete and total dud, was way smaller than we thought. It didn't break up pre-1AU, so we don't have as much to worry about with the meteors as we might have thought, but now we're kind of down to the point where we have to come down on one side or the other.
It's looking like to me that we're looking at something maybe on the order of the brightness of Venus, which I think some of the other scientists have said too. This full moon brightness, I think, is out of the question at this point. In observation, assuming it survives perihelion.
Yeah, if it were to explode or something, that could be a different story.
I think the months after perihelion will certainly be the ones to watch versus the next couple of weeks here.
Yeah, that's very possible. It's very possible. Well, what about the idea of inducing flaring from the sun? Now, I definitely want to, before we get into that, there are people who are taking this current solar uptick that we are in, one of the few that we've had amidst this otherwise disappointing solar maximum, and I'm being kind by calling it that. They're taking this and they're saying, oh, see, ISON's getting closer. See, it's really revving the sun up. We've gone over this many times, so I'll just quickly go over the points before. Those who know the sun know that even these solar upticks, which occasionally pop X flares and are mostly just a bunch of little M flares, are not very significant when it comes to a solar maximum in terms of major flaring. In the last solar minimum, where you can still technically have flaring, we had an X14. And the highest thing we've had at the solar max is an X6. It was back in 2011. The X3s this year were the highest that we've seen. We're just really not having that much going on. So, if anything, I'd say we're way underneath what we should be. So, I'm not saying you should blame ISON for the sun being weak right now, but you certainly can't say that ISON is making the sun go ballistic or revving up. Second, we're still, this uptick right now, the one we saw at the beginning of the year and the ones in 2012, appear to be preceded by sun-diving comets. And they seemed, it wasn't just, the little one that we see every few days. There were a couple of them. A couple of them were pretty big. They were very much visible on both SOHO LASCOs. And, at this point, it's really tough. If you have been watching diligently, it's tough to say, well, how do you just dismiss the comet flare connection? And I know that we've talked about this a little bit before. Billy, you and I have talked about this one-on-one a little bit more. But, all the experts, NASA, they fervently, absolutely deny that any such correlation exists. And the idea is that, look, these comets are too small. They couldn't possibly have anything to do with this. And I think that that's thinking too inside of their box of, oh, it's an impact factor. Thinking like, oh, a meteorite hitting Earth could cause an earthquake or a big tsunami, something like that. They're thinking much too directly.
Yeah, I'd agree. You know, I mean, if anybody's paid any attention to the sun divers, especially, I mean, it almost, as a visual, it's almost undeniable that they have an effect when they get in proximity within a certain distance.
Well, yeah, and you know what I think one of the giveaways to how this might function was Comet Lovejoy, and we've talked about this a few times before, but it'll be good to put it into perspective here. It was, bigger than just about all of the Kreutz sun divers that we've seen. It was a very, very big one, and it went through the corona. I mean, this thing went through the hottest part of the sun. People are saying, "Oh no, it didn't go through the sun," and it didn't. But it went through the hottest part of the sun twice. Once on the way in and once on the way out. And it probably spent a fair amount of time in there as well. And it really did not induce major flaring. Whereas when we see these much smaller ones completely shred up and basically get blown into ionized dust, just before they hit the corona. We see those ones as being the ones that really tend to induce flaring. And Xavier and Stellarium Current, you guys weren't here when Billy and I were talking about this last time, but if you take the idea that these comets have a ton of electric potential to begin with, which is one of the reasons why they light up like they do. And they get this potential from spending so much time far out in the system. Well, the difference between a comet that shreds itself and basically becomes ionized dust and one that survives perihelion and goes out of the system might not seem terribly significant other than the way that they look. And we'd often tend to look at one that survives perihelion with a giant comet tail beforehand and afterwards, like Comet Lovejoy, as being much more effective on the sun. But most of the energy of Comet Lovejoy, despite the terrific show it produced, is still inside that comet, flying around wherever that comet is now. But when you get a comet that completely blows apart, you essentially have the entire comet turned into plasma, ions, charged dust, things like that. And these are going to get captured in the magnetic fields and could create surges or disruptions, perturbations. In the video I put out just a couple of days ago when we had the X3.3, I made sure right in the middle of that video to focus as close as I could get on HelioViewer to the interacting magnetic fields. And you could see that it wasn't the big arcs that you see, it was these tiny little ones, very, very close to the surface. They appear, they disappear, they move around, and when they interact, that's when you get the flares. It's kind of counterintuitive to how you would think it would happen, but we do see this time and time again. It's the way that Xavier so awesomely portrayed the mega flare in How to Watch the Sun. That wasn't those big loops, that go from active region to active region. That was the little interacting fields popping up, and they interacted very, very close to the surface of the sun. And when you think about what I was just saying about what happens to a comet, all right, yeah, Lovejoy was fantastic, and the thing looked like it was, a blazing hand of God going through the Soho Lasco, but still, there's still a giant hunk of rock there that is flying through space and wasn't ionized, obliterated into dust, and inserted, essentially captured by the solar magnetic fields and interacted with it like that. It's a completely non-kinetic in the way that we tend to think of, or the way that NASA is tending to use to deny the fact that these have any effect. It's not that kind of kinetic interaction. It's very much electromagnetic. And I think that the fact that ISON is expected to survive perihelion, does that mean that, given everything I just said, maybe there's less of a chance it could induce flaring? That seems to logically follow from what I just said. I have absolutely no idea if this thing's going to survive perihelion. I like their little shred limit calculations, but we have no idea if those are accurate. That really is them just guessing, right?
Absolutely.
Yeah.
Yeah, it's hard to tell, and the mathematics get real sloppy when you try to predict the electric force. I mean, you can throw everything you know out the window because it's really complex. The interactions have so many factors and variables that to say ISON is going to cause a flare, we just don't know that. And there's not a lot of good evidence to support it, and there's not a lot of good evidence to deny it.
Yeah.
It's on the fence. It could go either way. And I can see Dr. Strong's argument. You know, he says they don't induce, but yet time after time we see flares being induced all the time by comets. So,
and they look so organic. You know, I remember Elenin, and there's been a whole bunch of sun divers too. And you know, it looks like a guy sitting in the bombardier of an airplane shooting off an oncoming missile. You know, and I think that's why the public or just the general viewer sees these things as the sun is pushing something out to protect itself. It's almost like it fires a CME to keep these things away, which really doesn't make any sense.
Yeah, especially because, you know, a lot of times the CMEs, you know, aren't going anywhere at the comet. You know, of course, the most famous exception to that being Comet Neat, where the CME basically tagged its tail and made it, you know, do the twist for a moment.
Yeah,
but
it just looks so darn calculated, and I think that's where people have a problem. I know I do.
Yeah.
Yeah, there's got to be some kind of connection point for these comets too as they're coming in. Maybe that connection point's overlapping an active region of the sun. Maybe that's what actually triggers the flare event like we've seen with Comet Neat. It's hard to tell.
Well, absolutely, and you know, if you watch in certain SDO AIA wavelengths and you watch the limb, when it appears that a smaller filament eruption appears to immediately precede a larger flare. If you look up into the corona where you can see the lines created by the magnetic arcs, you know, they are reacting and interacting all over the sun. And boy, I'll tell you, one of the greatest things, and you know, we can't just all of a sudden one day hope that we'll snap our fingers and people like Dr. Strong and NASA will just say, oh yes, there could possibly be a connection between these comets. But we do see us getting we do see us stepping closer. For example, spaceweather.com is repeatedly showing and pointing out these global eruptions on the sun. And it's not doing it as like, hey, take a look at this cool coincidence that happened on the sun. They're describing how all these magnetic fields are connected and interacting. And all you have to do is think about the umbral and coronal fields I show, where it's that twisting, the twisting sun, and it's got the blue magnetic field lines coming off of it, and it's got the red and the green coronal holes. Well, those are just the ones that extend up a little higher than the little ones that you see on the SDO AIA 171. Those are just bigger, and there are ones that extend out even further. You know, and these go to the planets all throughout the heliosphere. It's really tough to imagine that anything traveling this close to the sun wouldn't be interacting with the fields, which we know, according to those very same experts, all tend to interact with each other all across the sun. It's like everything they're saying leads you to the next logical step of saying, okay, well, if there is a major electric discharge with a comet, you know, an explosion, a plasmification of the ions, and a concentration into a magnetic field, given everything they've said, the next logical thing to say is, okay, it's possible these comets could induce flaring even on the opposite side of the sun. They just haven't taken that step forward to connect their own dots. In fact, they've gone and said that no, those dots that they've created do not connect, with which I completely disagree. But it is what it is. I have a feeling the Thunderbolts disagree as well. I know there's a lot of people listening who are Electric Universe proponents, so
Yeah, well, Hans Alphen described the plasma sheet as a current sheet of double layers. And when we see an object pass between these double layers, the positive charge will go towards that negative charge region. So if that body's negative charge, like we believe it is, there has to be an interaction electrically taking place. It is an electric universe.
That's as good a reason as any to keep watching, as we always do. This comet is both a tremendous and shameful topic of discourse on the internet. Like every significant comet the last few years, despite even the record observations on this one from both pros and amateurs, it shares the stories of UFOs, doom, and everything else we've heard time and time again now, but which does seem to snare new viewers every time, so perhaps we should thank the fearmongers. But I'd rather thank those like the team of Gary, Whitmore, and Kay for bringing us such an unbiased and down-to-earth education page for those of us trying to gain a better understanding. This site has had its original photos of the comet stolen and photoshopped numerous times just to spread fear about this comet. Unfortunately, that malpractice has also spread to other amateurs posting their pics to galleries on the internet, like this one, hosted by Dr. Tony Phillips at spaceweather.com. It helps to find people who really know what they're doing, like Francis Walsh, because frankly, folks, if it sounds too crazy to be true, there's probably a good reason for that. I highly suggest you learn to use the JPL and where to find the best sources. Eyes open. No fear.